we're going to finish out this last section with the type of problems you might see when it asks you in this format. Solve the differential equation given the derivative subject to the initial condition. So it wants the original function. So they give us a derivative, they give us an initial condition, and they want the original function. So the first thing we're going to do is if we have f prime of x is equal to 6x squared plus x minus 5 dx. The original function that we're looking for, we can find it by taking the antiderivative of the given derivative. Okay, so we're just going to start with that. We're looking for our original function, so we take the antiderivative. You can pull that 6 out front, and you just get x to the third divided by 3, which would be here, but you have that 6 that's sitting out front, so we would just simplify to 2. And then for the second one, I'm going to have x to the n plus 1 over n plus 1, so it's just going to be 1/2. And then that's minus 5x plus a constant. Now, we don't know what the constant is, but this information will help us find out what our constant c is. So it's saying if you plug in f of 0 when x is 0, everywhere that there's an x, plug in 0. To see if you can find out c, and that makes this pretty easy here. So we'll have f of 0, which is up here, and is 2. F of 0 is 2, so 2 is equal to c. Then we will determine that our original function is just going to be 2x cubed. We come back here and we plug in c. 2x cubed plus x squared over 2 minus 5x plus 2. Alright, and we'll look at another one. Solve the differential equation f double prime, so they give us the second derivative this time, and an initial condition, and the first derivative initial condition. So we're going to have to use antiderivatives to get ourselves back to the original function. And we'll have to do that a couple of times. So we're just going to take our time. Now, if they give me the second derivative, then my first derivative can be found by taking the antiderivative of that, or evaluating the indefinite integral of the second derivative. So we'll have this. So if they give you the second derivative, the way you get the first derivative is to take the integral of that. So integrate it. And then here, that's just going to be, you could pull the 5 out front, and the integral of cosine is sine of x. You can pull the 2 out front, and just have the 2, but the antiderivative of sine of x is negative cosine of x. And then remember, we always have plus a constant. So this is our first derivative. Now we don't know it exactly because we need to figure out what is c, just like we've done in the past. But they did give us information to work with because they gave us the first derivative initial condition. So f prime of 0, that means everywhere there's an x, plug in 0, is equal to 4, so I can put a 4 in here. And that's just going to be sine of 0 is 0, cosine of 0 is 1. So when I have this, I'll have 4 is equal to negative 2 plus a constant. And I solve for c, so 6 is equal to c. And with that information, I can now write my first derivative, which you come back up to this step and plug in your c. So I'll have 5 sine of x minus 2 cosine of x, and then my c is 6. So now I have my first derivative, but I'm still not finished because I want the original function f of x, so I have to keep going. So how do you think we would get the original function? Good, take the integral. Well, let me just put it here. So if I take the antiderivative, if I integrate the first derivative, then I can get back this will give me my original f of x function. Okay, so we're going to take our time and move through that as well. And this is just going to be, if you pull the 5 out front, you're just going to have the 5, and then the antiderivative of sine of x is just going to be negative cosine of x. You can pull the 2 out, the negative 2 out front if you want, and then you evaluate that. I'll have derivative of cosine is sine, so negative 2 sine of x. Antiderivative of 6 is 6x, and then I have plus some constant, and because we already used c up there, I'm just going to use d. And we need to figure out what d is. We come back up and they give us information about the initial condition. So f of 0 equals 3. So f of 0, everywhere that there's an x, plug in 0 and evaluate. And then f of 0 they told us was 3. So 3 is equal to negative, find cosine of 0 is 1. Sine of 0 is 0. That's just 0. And that's d. So we'll have 3 is equal to negative 5 plus d. 8 is equal to d. So now that we know d, we can come back here and plug in the original function to find f of x. That's just going to be negative 5 cosine of x minus 2 sine of x plus 6x plus 8. So in this particular case, if they give you the second derivative, you integrate that to get the first derivative, and then you can integrate the first derivative to get the original function f of x. Now, of course, we need initial conditions to figure out the constants like the plus c and the plus d, but the process is pretty routine. Let's look at one more types of problems. They'll say find the equation of the curve given the derivative and the indicated point on the curve. So they're given the derivative here, your dy dx. So if I want my original function, which is just y, because this represents the first derivative right here, that's the other notation for it. So if I want my original function f of x, or I can just say y equals because that's equivalent, I'm looking for y, and the way I get y is to take the integral of 3x squared minus 1 dx. So we use integration to get to the original function. And so here, you could pull the 3 out front, and then I have x to the third divided by 3, so then that just simplifies to x to the third minus x, and then we have our plus a constant. Now, to figure out our constant, we have values up there. So we'll have when x is 2 and a y is a 4. So y is 4. X is, let me plug in my values. X is a 2. 4 is equal to 8 minus 2 plus a constant. We can figure out c. Negative 2 is equal to c, so we can go back and write our original function by plugging in our c there. So y is equal to x cubed minus x minus 2. So for that example, it'll say find the equation of the curve when they give you the derivative and they give you a point on the curve. So that'll be the types of problems that you can see with antiderivatives and integration. For the most part, make sure you take the time to go back and look over these and make sure you know these. Let me erase this. Especially, like I said, this one's very common. This is when we can pull the coefficient out front. That's if you just have a coefficient, you're going to get x, and if you get the integral of 0, you get just a constant. So you want to make sure you have a good knowledge of those. common indefinite integrals.